tonight if I can stick around.
Okay. Yeah, you sound like you're
So I need to
not doing well
like I
tonight,
said,
and I'm sorry to hear that, see that.
I was having a great week. I think I just need to go get some meds. I don't have anything
Yeah,
to step out of. So.
yeah. So this one is mitigating threats to the access layer. I put this image in here back to the access layer. We're talking about the Cisco 3-layer model when we refer to the access layer. So we have the access, distribution, and core layer. We're talking about the access switches, the ones that we typically will see in the rooms and the floors and the wherever where we're going to plug devices into. So we want to be able to protect those devices, and protocol that we're going to use for that is 802.1x. Port-based authentication. It can be used for a number of authentications. In the ccnaldc.blogspot.com, I just put a link into a video if you want to watch on how to configure 802.1x, but it's for a wireless access point. The process is the same. And then we're going to configure DHCP snooping. DHCP snooping, and it's really not a big deal to configure. You go in and give the command IPDHCP snooping. What it does is prevents rogue DHCP servers, and I have no clue why they named it snooping. So first we're going to start out talking about native VLANs, and if you remember, the native VLAN is the one that carries the untagged traffic on trunk ports, and we looked at it. If we have a native mismatch and we start out with a native over here with an untagged packet of 50 and it's 60 over here, we go across the trunk, it comes in here, says it's untagged, it's going to be shifted from one VLAN to the other, VLAN hopping. One of the attacks that people tend to use a little bit. A trunk can carry both tagged packets, .1Q packets, at the same time. No real big deal there because we've said that a trunk carries everything, right? A trunk equals all VLANs, tagged or not. The untagged VLAN by default is VLAN 1. The default VLAN is the native VLAN, and on and on and on. When a default port VLAN ID is assigned to the trunk port, all tagged traffic will travel on the default port. Yeah, VLAN ID for the trunking port. All untagged traffic. And again, the default, when we start out, the default, and the native, and all the ports are all on VLAN 1. We can modify those things. We can change the native VLAN if we want. And in a lot of cases, it's not a bad idea to do that, to send it someplace else and to send it someplace where there are no ports. I really think that today the odds of having untagged traffic not having a VLAN of some sort is, sort of remote. VLAN untagged traffic would be a hub. A hub would be a device that would not tag traffic, obviously. Assume that all untagged traffic belongs to the default VLAN. VLAN is also referred to as the native VLAN for the trunk port. We'll send all egressing traffic with a VLAN ID that is equal to the default VLAN ID as untagged. Boy, now they've gone through, I think, 14 or 15, not really, 4 or 5 different statements that all say the same thing, I think, that VLAN 1, native VLAN, is untagged. So that means that VLAN 1, the native VLAN, when we start things up, VLAN 1, when we send traffic on VLAN 1, if we don't create additional VLANs, then all the traffic's going to be untagged, and it's going to go over the native VLAN. Other egressing packets will be tagged by the trunk port, and they're tagged on the way out, and the tag's taken off on the way in because we have that shim in the middle, the .1Q shim. That makes it a non-standard frame, and if we didn't do that, and a device got a non-standard frame, it would just simply drop it. It would ignore it. When you've not configured the native VLAN, the trunk port uses a default. So if we don't change it, it's going to be 1. If we do change it, we have to change it on both sides of the trunk. If you don't, you're going to get a lot of error messages. And I think that you can try it out. That the ports themselves will actually go into air disable mode, and you'll keep getting native VLAN mismatch, and it'll tell you what the VLAN numbers are for the configured VLANs on both ends, and you can then go back and fix that when you do that. I had that problem on the CCNP test, one of the configurations, and I kept clicking the wrong switch and changing it, and it says, I still got a VLAN. I said, I know I'm doing this right. Well, yeah, you got to do it right on the correct switch. So that's another thing when you're doing configs on the Cisco test. Be sure that the device you're working on is the one that you think you're working on, that you should be working on. By default, and we looked at this last night, the trunks will be able to send traffic to and receive traffic from all of the VLANs. And by default, all of the VLANs that we create are going to be allowed on the trunk. So all of them are going to be initially allowed. If we want to prevent a specific VLAN from passing traffic over the trunk, we can remove it, and we looked at the VLAN allowed switch port mode trunk VLAN allowed command, and if we need to do a VLAN add or a VLAN remove in order to add or remove VLANs. If you just do the VLAN allowed and then put a VLAN number in there, that's the only one that's going to be allowed when you do that. So we need to add or remove VLANs if we don't want them. If we don't want the native VLAN, we don't want untagged traffic, then we can remove the native VLAN from the allowed list. And each of those is going to have an allowed list. Let me see if I've got a trunk here. A trunk here, just so that we can. Let's see. And I don't, so let's go to whichever port this is, Fast Ethernet 01. And this is the one that's going to interface fast 0/1. And we can say switch port mode trunk, and it should create a trunk. The other end on the new switches is going to be dynamic auto. The old switches, they're going to be dynamic desirable. New switches, we plug two switches together, we don't get a trunk port. Show interface trunk, and we have our trunk here. VLANs allowed on the trunk 1 to 1005, so all of them are allowed. And this says VLANs allowed and active in the management domain, VLAN 1, because that's the only one that we have. I haven't created any additional VLANs on this thing. And then VLANs in the spanning tree, forwarding state and not pruned, none. So we can see which VLANs are allowed on the trunk by using the show interface trunk command to find those and which ones, and by default all of them are allowed. If we don't remove VLAN 1 from the list because it's enabled on all the ports, VLAN 1 may be a very big spanning tree topology, because if we have a whole bunch of switches and we haven't created these things, haven't made other VLANs, then all of the ports are going to be in VLAN 1. You may or may not want that to be the case. Could result in problems with the spanning tree convergence. When it's removed from the list, all the data traffic for VLAN 1 on the port is going to be blocked. The control traffic will continue, and we really hadn't talked about control traffic. There is the layer 2, I'm turning the heater on. The layer 2 control traffic, spanning tree protocol, CDP, and then when we talk about 802.1x, the 802.1x control traffic, all of that is going to continue to go across the trunk so that the management traffic isn't stopped by taking that VLAN off of the trunk. VLAN allowed, and this is just an image here that says VLAN trunks allowed 10, 9, the native VLAN 99, so we've changed the native VLAN on this thing. And the VLAN 20, the student has no connectivity to the server, obviously, because its VLAN 20 is not in the allowed list. It may be intentional that we don't want students to be able to get to that server. It may be a configuration error that prevents the students from getting there, but we can see with the show interface trunk which of the VLANs are allowed on the trunk. And when you do that, you do a configuration on one side, you got to do it on the other side too. This is not one that they'll talk. We give it an allowed and on one switch, and then it automatically tells it on the other switch. So we may be allowed to go one direction and not another, which is kind of an odd occurrence, but that could happen to you. The steps to configure the allowed VLANs, interface, slot port interface, fast Ethernet 01, command switch port trunk allowed VLAN, and then the VLAN list all none, add except none, remove. So add or add except, if we do all, it puts them all on. If we just do a switch port trunk switch port trunk allowed VLAN 11, then 11 is going to be the only one in the list. We would, if we wanted to put it in additionally, we would say add. And if we wanted to take it out, we would say remove for the list. And down here is the example switch port trunk allow VLAN 25 through 40. Those will be the only ones that will be allowed on that one. The non-default native VLAN, if we want to change it, and hopefully we have talked about that enough, we go to the switch port, we go to the port interface that the trunk is on, and if it is a port channel, a channel group, a bundle, which we will do in the next one, we can specify a different native VLAN. And again, this is one that needs to be specified on both sides of the trunk port. Otherwise, you're going to have a native VLAN mismatch when we do those things. And I guess that we could try that out here. So is it switch port interface? Big T interface fast 0/1. All right. Yeah. Switch port trunk, and then allowed. We can do the allowed command. Allowed, and then all of the VLAN. And then the question mark. Don't be afraid to use the question mark when you do configs. When you're actually doing configurations on the Cisco test, the question mark works and the tab key works for the completion. And the tab key prevents a lot of typos, at least a lot. For me, it prevents a lot of typos. So we have none, except, all. We can add those. That's not what I wanted to do here. Switch port trunk, and then we can do native, and then VLAN, and let's just say 30. I don't really have a VLAN 30, and theoretically, show interface trunk, it says that the native VLAN is 30. On the other end, I guess we should be sure that we actually formed a trunk over here, huh? Yeah, here we go. Yeah, I'm getting the VLAN mismatch. Native VLAN mismatch. Native VLAN mismatch discovered on fast Ethernet 03. 1 with switch fast Ethernet 0130. So saying that my side is 1, the other side is 30. So we will get the mismatch error message. Let's go back here and change this back. Config T. And let's change it back to 1. Oh yeah, because we got to be on the interface. Okay. And now I should be able to do the VLAN. So that should stop the error messages over there. And we can look at that a little bit later when we do that. So set the native VLAN. Native VLAN is where the untagged traffic goes. This is just something that I found's got the number of commands to do these things. Switch port mode trunk, switch port trunk. Native VLAN, which is what we just did. Switch port trunk allowed the commands that we would use in here. The interface, show interface, and we have looked at that. Displays the configuration of the interface. Show interface fast Ethernet 01. Interface switch port information about the ether links includes the information about the access and trunk interfaces, and then show interface brief displays the information about the configuration information in it. Authentication, and again, so we kind of jump around here, and .1x authentication is the thing that is one of the primary focuses of this one. But authentication is when we prove who we are, and you guys have all done a myriad of ways, I'm sure. Username and password is the most prevalent one. Smart cards, fingerprints, thumbprint, iris scan, facial recognition. And I get phones. Mine doesn't. Well, mine actually may, but can use facial recognition. You got the patterns. So all sorts of different things to prove who we are. And a combination of username and password is one we usually use. The switches and routers support both local authentication and remote authentication. Local authentication, when we go into the device and use the username and password command to create users and passwords on the local device. We can also use Radius or TACACS. TACACS is a Cisco server, authentication server. Radius is an open source. If you're running Windows servers, it supports Radius authentication. So we can use, yes.
In the mixed environment, are there other manufacturers that are either allowed or support TACACS Plus?
I don't think so. Everything that I've read, and I've never tried to buy one, it's a Cisco proprietary. It gives you a little bit more capability than Radius does, but Radius, Microsoft does it. There's open source Radius. So you can, it's available in a lot of places. Uses a challenge and response mechanism when we do that. And a challenge response is it sends a challenge, and then we encrypt the challenge with the password, send the hash back, and then it does the unhashing. It knows what the challenge is, knows what the password's supposed to be. So we don't actually send the passwords encrypted across the network. We send a hash of the encrypted challenge, if that makes any sense. Provides support for messaging and encryption based on the security protocol selected by you in the authentication. When we do these things, we create what's called a methods list. So we're going to go in and we're going to do a AAA authentication authorization and accounting. We'll do a new model, and then we'll give a methods list to say, okay, first I want you to try the Radius server or the TACACS server, whichever one we're using. If it's not available, maybe we use a local database. If you can't get to the local database, and I don't know why that would happen unless it was corrupted, then go to maybe the enable logon. This does not mean that if I type in my username and password and mess it up 14 times, then it'll go to the local database. It only goes down the list if one of the methods isn't available. Can configure by defining a named list that consists of authentication methods and applying it applying the list to the various interfaces. That's the methods list that we can do that. A methods list must be used to define types of authentication to perform and the sequence in which the authentication will be performed. And the sequence is the order that they're listed in. We would log in Radius, then local, which would be the local database, and then maybe enable when we do those things. It's applied to a specific interface before any of the defined authentications. Got to be, what it's saying is we've got to configure it before we're going to use any of these things. The default methods list will automatically, says there is a default methods list automatically be applied when you don't define a method. We need to define the methods list will override the default methods of these things. So what we want to do is to define our methods list, and it's a sequential list. Allows us to designate one or more security protocols. Let me see if I have one here. If I can get packet tracer going again. I'll put this over here. I don't know if it actually has the configuration or not. If not, I'll do one at the break. And it does not. So I will set one up and show you. Actually, I think your lab does it, but see if we can do a methods list on this thing. So it allows us to designate one. We'll use the first method to authenticate the users. If it's not available, it'll go to the second one. So when a method does not respond, doesn't mean that we do it wrong. It means that it does not respond. So here is the command AAA authentication, and then the methods, the login, enable ARAP, point-to-point protocol, different methods that can be used in the methods list. Authorization tells us what we can do. So we have authentication, where we prove who we are, authorization, where we get a list of things that we can do. What can we actually use? What resources can we use? Can we make changes to whatever else? And a method for remote access, one-time authorization, or an authorization for each service. So we can get more specific. Takes a little bit more configuration than what it implies here, like, okay, yeah, it's just going to work, but you've got to go in and specify what can be done by each user. And we actually usually do it by a grouping and commands. We specify the commands that can be used at the different levels, the access levels in the devices themselves. Switches provide authorization by using attributes that are downloaded from the AAA servers. Security radius and TACACS allow specific rights to the users by associating attribute value pairs with them. And all the authorization methods can be defined only through AAA new model. And then accounting is basically what we have done. Collecting information, logging the information locally, or sending information to the AAA servers. Maintains a log of every management session used on the devices. Collected by the accounting can be used to generate reports, troubleshooting, auditing purposes, tracking of services. When you activate AAA accounting, the network access server will report the user activity. Each accounting record compromise the accounting pairs, and all the methods can only be defined through AAA. It is not available in the local databases. It's coming up to the top of the hour. Let's go ahead, and what I have here is my packet tracer, and here are the commands. We have to specify the radius server address, and then AAA new model tells us that we're going to use this. And then authentication, I did login. Default was group radius and then local. So first we're going to use the radius server, and then if that doesn't work, then we'll use the local. And then for telnet, login authentication default, and then for both of the telnet lines. So what we have when I go to this router, and this is where it is configured, it's going to ask for my username and then my password. And if I do a show run here, all of those things should be there. AAA, here's the new model. We have to give that command to tell it that we're going to use this type of authentication. And then authentication for login. Login, the default, we're going to use group radius, and after that, local. We could add like none at the end if everything else fails, then you don't want any authentication. But you can use those, and then on down here somewhere, I see there's the radius server definition, and here's the telnet login authentication. Up here, the local database username, privilege level, and then the password that would be used there. Those are, unless we give the service password encryption, those are going to be clear text passwords. So that's the how to log in and the radius. And if we had a TACACS server, we could use TACACS instead of radius. We would substitute the word TACACS where we have radius. This is a different type of authentication because it says it's port-based authentication. What that says is we're not going to authenticate somebody to a router, which I just did in that little demo. We're going to force them to authenticate individually in order to activate the ports that their devices are connected to. Quite a bit of configuration, actually some configuration here. We did this one time just to prove that we could do it. It worked well. We used radius out of Windows and then used the Active Directory database for users to log in to activate. What this says is that the port on the switch is going to be down, going to be turned off until the user actually gets authenticated onto the system. We do a similar thing when we log in with Active Directory when we log into the computer, but this goes a little bit further. And again, in the Blogspot page, ccna.ldc.blogspot.com, I put in a demo on how to do it for a wireless access point. Wireless access point, instead of using the pre-shared key, you use this type of authentication. It allows you to make people use their username and password, and again, you can go back to Active Directory or any other authentication database that you have in order to use this. So it defines a client-based access control which prevents clients from connecting to the LAN through publicly accessible ports unless the clients are authenticated. So this is one I told you about. People would come in and plug in their laptops, and then we did port security, and that cured that problem. But we could also have done that. A salesman comes in and, oh, here's a port in the waiting room. The guy plugs in, and now is he on your network or not? A number of ways that we can do security, and there is no right or wrong answer, like Joel was talking about. What do you got to do? You got to make a decision. How much security do you actually need when you do those things? So we're going to have the device that's trying to get authenticated down here. We have port traffic permitted before it, EAPOL, Extensible Authentication Protocol over LAN. The packet exchanges, the data exchanges in order to actually do the authentication. CDP, the Cisco Discovery Protocol, and STP, Spanning Tree Protocol, are going to be allowed, and then later on we're going to say, okay, yeah, you can do phone calls too. We're not going to block phone calls. Just the data port is the one that's not going to be, the data portion of the port, the one that's not going to be available. So authentication, server authenticates the client and makes it available for any services offered on the switch. So what it does is brings the switch port up. It allows the EAP, the CDP, and the STP data to go through before we get authenticated. These are the roles, the things that we have. Client, they kind of mix some terms here. Supplicant is really the proper term for the device that's trying to get authenticated. It's the one that we would normally call a client, but in this case it's going to be called the supplicant. The workstation, the computer, the laptop, the whatever that's trying to get authenticated to the device. Now, we're not authenticating the user onto the network to where they can use the particular printer, get to certain directories and those sorts of things. We're authenticating the device to allow it to connect to the network. We may use the user's credentials in order for that to happen, or we can configure it with certificates in order to do that. The authentication server, that is where the Radius and TACACS, other types of authentication servers come into play. So we have an authentication server, and then the authenticator is the device, the switch, the computer, the router that we are trying to get access to. And in most cases, many cases, it's going to be a switch, because remember, this is access layer that we're talking about. So it's going to be the switch that's going to check the authentication before it actually turns the port on. This is the process for these things. The client here sends an EAPOL, Extensible Authentication Protocol overland start, saying, hey, I want to do something. Would you wake up switch? The switch sends it a request identity. Then we send an identity response, and that gets relayed, the Radius access request, that gets relayed to the Radius server. The Radius then sends the challenge, because we said it's the challenge and response, goes back to the device, and then the EAP response goes back here. And after it happens, then we either get an accept, a success, or a failure message. This over here, wireless access point, same basic thing. Authentication request, identity request, username, relays to the server, authentication challenge, authentication response, authentication success or failure, and then the challenge is related to the server. The challenge here is we can challenge after the re-authentication is what it's called. We can either have a single authentication for these things, or we can require re-authentications. So the process, client identity has a valid authentication. If the client identity is valid, the authentication is successful, the switch will grant client to the access, turns the port on. If authentication timed out while exchanging the messages, and a MAC authentication, a thing called a MAC authentication bypass option is enabled, we're going to have all sorts of special cases in this thing. So let's see if we can do some of this stuff. While waiting, it's timed out while waiting, and the MAC authentication bypass option is enabled. If it times out, it's maybe not available, it could be down. Not being able to communicate with it for whatever reason. The switch will be able to use the client MAC address for authentication. If it's valid and is successful, the switch will grant client access to the network, turn the port on. If the MAC address is invalid and it's not successful, the switch will assign the client to a guest VLAN if we have configured this guest VLAN. A lot of times these slides imply that, oh, these things just happen automatically. They don't. You have to have configured that guest VLAN and specified what it is. Limited services, when you have configured the guest VLAN. If it receives an invalid identity from the 802.1x capable client and a restricted VLAN is also specified, the switch will be able to assign the client to a restricted VLAN that can provide limited services. This is kind of some key stuff here. 802.1x capable client. Not everything is. All the new Windows machines are, and all of the new Linux machines, as far as I know, are. The softwares are. If you have some older devices, older operating systems, you may have to install the 802.1x client to them. If radius authentication is not available, it's down. You have enabled the inaccessible authentication bypass option, another bypass option. The switch will grant access. Inaccessible authentication, the radius server is inaccessible. Authentication and the message exchange. In this, we can enable authentication on a port using the authentication port control auto.1x port control auto interface configuration command. I can't do a demo of 802.1x on Packet Tracer because it doesn't support it. I can't do it on GNS3 because it doesn't support it. You actually need a switch, which I don't have, in order to make this thing, because you have to use the ASICs, the integrated circuits, in order to make this thing work. So the control auto or port, authentication port control auto, or the .1x configuration command. When we use these, the switch will initiate the authentication when the link status changes from down to up, or periodically until the port remains in the up state and is unauthenticated. Send the EAP. Switch will send the EAP request identity frame to request its identity. The client responds the little image that I had earlier to the identity frame. If during boot up the client did not receive the request identity, that's when we get the EAPOL, the start frame. It didn't get the request identity. It may or may not. If it didn't, it's going to say, okay, ask me to identify myself. Switch will begin its role as the intermediary and start passing the EAP frames. The switch port will become authorized. If the authentication fails, authentication will need to be retried. The port may be assigned to a VLAN that will provide limited access. And this is one that, as we go through this, some of these things are going to be, you're going to get tired of hearing some of it. Ports and authorized and unauthorized. Authentication will grant the client access to the network depending on the port state. The port will start in an unauthorized state. It's not configured as a voice when a port is not configured as a voice VLAN. It will disallow all the traffic meant for except the 802 to the EAPOL, CDP, and STP. All of those things, the management frames still are able to go through. On the client successfully authenticated and will allow all traffic to flow normally when it's in the authorized state. Ports configured as a voice VLAN will allow the VoIP traffic and the 802 packets before it's authenticated. Will request identity of the client. If the client that connects to a port does not support 802.1x authentication, an older client, the client does not respond to the request, the report, it's going to remain on unauthorized, which is not running the 802.x standard. When we connect what all this is saying is that if we have a not supported client, then we're never going to bring the port up. We'll remain in an authorized state. If we have a client, an 802.1x client, but the device isn't configured to require 802.1x, then it's going to eventually assume, well, I guess it's authenticated. So then the client will start sending frames, assuming that it is in an authorized state. some different configurations, and this is like, okay, why did I go to all this trouble? Because we have some states here. One is a forced authorization, which is one of the configurations that we can do. Causes the port to change to an authorized state without requiring any exchange, so it's going to authorize it. Force unauthorized will make it so that it can never be authorized. Auto is the one we want to use, enables the authentication and causes the port to start in a non-authorized state and then go through the process to become authorized. Request for identity, we'll use the MAC address to uniquely identify each client that's attempting to access the network. Switch stacks, we talked about them. We're going to go through basically the same thing. When you add a switch or remove a switch from the switch stack, authentication will remain in effect unless it is the switch that's connected to the radius server. The ports that are already authenticated and do not have periodic re-authentication remain authenticated. That are already authenticated have periodic with a .1x will fail the authentication process when it is reinitiated, because then this is when the switch that was connected to the server is removed to fail. Otherwise, the switch stack, we can take switches out, put switches in, nothing changes. But if we break the connectivity to the radius server, then we have issues with it. If an ongoing authentication is going to fail because it's an ongoing authentication, but it did not complete the authentication. So all of this is saying that if we remove the switch from the switch stack and we don't have a ports that are authenticated and don't have a periodic, will stay authenticated. That are authenticated and have a periodic authentication will fail the re-authentication. They'll stay authenticated until the re-authentication goes on. If we're just getting logged in, it's going to fail, and the switch fail comes back on and rejoin to the stack. The authentication status will depend upon the boot up time. We're going to go back to the process that we had. Authentication is attempted. Say if the switch is booted and authentication of the radius server is re-established before authentication is attempted, the authentication may be successful, otherwise it will fail. So different things that can happen in the process itself. The modes that we have, single host or multi-host. And single host, in my mind, I would say single host is we have computers out here connected to it. Multi-host, we'll do something really odd and we'll put maybe a hub out here. And then it's connected to this .1x port. If we use single host, connect one client to the port. If we have multiple hosts, multiple hosts can be attached to the 802.1x enabled client. We have a situation here that an individual out here, one of these individuals authenticates. Everybody gets authenticated to the port. They log off. Everybody gets unauthenticated to the port. If a port becomes unauthorized due to failure of the re-authentication, the switch will deny access to all of the attached clients. When it's enabled, to be able to use the authentication to authenticate the port and port security in order to manage network access for all MAC addresses, including the client. So different host methods to use this authentication process. Accounting, 802.1x, accounting has to be enabled, defines how users are authorized and authenticated for network access, does not keep track of network usage. So what it's going to do down here, successful user authentication, log off by the user, the status change in the link up or down, successful re-authentication or failure of the re-authentication. It is not going to be one of those things in the accounting that we would be able to go back and use it for billing purposes, for instance. It does not keep track of the network usage. It only keeps track of did we get authenticated, when did we get authenticated, did we get re-authenticated, those sorts of things. The attribute values that can be the information sent to the radius server is sent to the form of attribute value pairs, input octets and output octets on these things. And what we have here is the start interim. The packet is used for sending updates during the session, and then stop packets. So we have stop interim and stop packets that we're going to be able to see with that. With a VLAN assignment supported by Cisco switches, so we have another one, say with VLAN assignment, and in this case, the radius server will send the VLAN assignment and configure the switch port after an authentication. So this is another kind of cool thing that automatically assigns a VLAN to the port based upon the authentication. Database maintains a username to VLAN mappings. So this is another one. Oh yeah, this is really cool, and it is really cool, but it also has quite a bit of configuration that has to take place, and it's only supported on certain of the devices. It's authorized, and these are the it relates to the voice device authentication is supported with multi-domain host mode, and the later ones, if a voice device is authorized and the radius server returns an authorized VLAN, the voice VLAN on the port is configured to send and receive packets and on the assigned voice VLAN. So we can assign VLANs to the port. We can assign access control lists to the users on the ports. If we do that, if we have like a switch or a router ACL, the port or the 802.1x will say the port ACL takes precedence. It overrides the device ACL. Different levels of access. Let's see, when a radius server authenticates, it will retrieve the ACL attributes based on the identity and send them to the switch. It will apply the attributes to the port. It will remove the ACL when the session is complete. It does not go into the configuration, into the running configuration file. It just gets applied by the protocol. The switch does not store the in the running configuration. So be able to configure the router ACLs on the same switch. The port ACL takes precedence over the router ACL, what we said before. When you apply port ACL to a VLAN interface, the port ACL will take precedence over the input router. So if we send these access control lists, they're going to be the ones that are always going to take precedence. With a guest VLAN, here we go with some more. If a guest VLAN is configured, 802 will allow you to provide limited services to clients. Can be used to allow clients to upgrade to the 802.1x authentication. Whatever we think we need to do with the guest VLAN are supported in both single host and multi-host. It is enabled. The switch will assign a client to the guest VLAN if it does not receive a response to its EAP request. So more configurations that we can do makes things better. It doesn't receive a response, which means it's not capable. Then we put it on a VLAN that will allow it to become capable. Restricted VLAN, kind of like the guest VLAN, but this one is authentication failed. On the switch stack, be provided limited services to clients. Maybe we won't let them on the network, but they can use the internet, for instance. Limited services. don't access another VLAN because they failed the authentication process. Can use a restricted VLAN for a limited set of services without valid credentials. Again, we've said this, I think, several times. In the absence, if we don't have it, the client will attempt a failed authentication. The switch port will remain in blocking state, and the user won't be able to do anything. Configure the switch port on the restricted VLAN state after the specified number of authentication attempts until the default 3 attempts are completed. So once it happens, if we have it, they're going to get to the restricted VLAN. Otherwise, they're not. Some more exceptions here. Inaccessible authentication bypass when it can't reach the radius server. We talked about that. Can use the inaccessible authentication bypass feature if it's configured. Can be configured to connect new hosts that cannot be authenticated to the critical ports. Critical ports are the ones that are protected by 802.1x. Attempts to connect, the host will be moved to the user specified access VLAN or critical VLAN will give limited authentication. The administrator will give a limited authentication to the host. Tries to authenticate, it will check the status of the configured radius server. Only when the server is available, the switch can authenticate the host. When the radius servers are unavailable, the switch will grant access to the host and put the port in a critical authentication state. Special case authentication. So again, inaccessible bypass, the radius server is inaccessible. If we have configured this mode, we can get authentication. Voice port, special access port associated with VLANs, the VLAN voice identifier. This is the VLAN ID, and the port VLAN ID is the data VLAN ID. The voice is used by the IP phone. A single host on the voice VLAN only, the IP phone is allowed. Multiple host mode, the port VLAN ID, additional clients can send and receive traffic on the voice VLAN. And then the supplicant authentication can affect both of these when multiple host mode is available on it. If we configure this with port security, both of them are invoked. Port security, switch port security, when we do that, it'll check the port security, check the MAC address, and then if the MAC address is valid, then we can authenticate. These are two separate things. One is authentication, 802.1x. Both are enabled. 802.1 authentication will authenticate the port, and then port security will manage the access for the MAC addresses. So if we have both configured, both will be used. Wake on LAN, the magic packet, and what all of this says is that if we have 802.1x configured and we try to wake a system up with a magic packet, it's not going to happen, because with Wake on LAN, the port becomes in the unauthenticated status. There's no way to get it authenticated with the Wake on LAN. Will become unauthorized. Let's see. Feature for dormant PCs, Wake on LAN. Can be used in environments when you want to wake something up, maybe wake them up to do an update in the middle of the night. The port is unauthorized when the host uses the Wake on LAN. When that uses the Wake on LAN is attached to the port, the host is powered off. The port will only be able to receive the EAPOL packets. Cannot reach the host when the PC is powered off. It's not authorized, and the switch port won't be open. So what this is all saying is that if we have this configured, the Wake on LAN, the magic packet's not going to go. Wake on LAN is not going to be effective in this environment. authentication bypass, MAC authentication bypass, and I think we kind of have maybe addressed that at least a little bit sideways. 802.1x, which will use the MAC address for the client identity. The authentication server maintains a database with the client to MAC addresses for these things. Detects a client with a 802.1x port. It'll wait for an Ethernet packet from the client. Sends a radius access request frame with the username and password based on the MAC address to the authentication server. If the authorization is successful, the switch will grant access to the client. So another one of the exceptions that we're not actually going to use the username and password for these things. Network access control, NAC layer, network admission control. I don't know why I say access. Admission control. Permit the following tasks. Download the termination action radius and termination timeout radius. Certain radius packets are going to be allowed on this thing. Set the number of seconds between re-authentication attempts. This is a session timeout for the radius attribute. And get an access policy against the client for the radius. Set the action to be performed. The attribute tries to re-authenticate the client when the value is either default or when the value is not set. The session will end when the radius request re-authentication process will be started on these things. Show.1x privilege exec command whether the .1x has been configured on the device. What all this is saying is will permit the following tasks. The termination action, it's going to allow us the timeout session. How frequently are we going to have the re-authentication happen on these things? MDA is multi-domain authentication, and what it does is allows the phone and the data device to authenticate on the same switch. And this is, when we get into this thing, supported by switches that allow both data and voice devices to authenticate client on the same switch. The ports divided into a data domain and a voice domain. So we're having separate authentications for these things. That the voice device gets authenticated first, but the device does not enforce the order of authentication. And the Cisco phones use CDP to notify the switch of changes in the link state. It uses CDP to sometimes find its configurations also. CDP, is, we said, you can turn it off if you run in Cisco phones. Probably not something that you want to do. And then if all else fails, we can have web authentication. Layer 3 authentication mechanism that protects the data during the web-based authentication. So we're going to protect the data here. Authentication work on any node that runs a web browser. Can be combined with a pre-shared key or a layer 2 security policy. You can set the MAC authentication bypass, all of the things that we've talked about. The authentication fallback command to configure the port to use web authentication as a fallback method. Nothing else is working, and then we can do a fallback to it. Again, what we're doing, all of this stuff, there's lots of exceptions to it, but the whole objective is to leave the switch port down until the user gets authenticated to it. And back to, I think, a question Joel asked, where do you start? How much security do you actually need? And that's why you're going to make the big bucks. There's a 15-minute lab. What I'd like to do is, since we don't really have that many slides left, is to go ahead and finish this lecture. What I'd really like to do is consolidate all of the labs to the end of the class, because I think that you're probably already tired of listening to me, but after we do the next one, you'll really be tired of listening to me. DHCP snooping, we talked about, validates the DHCP messages that are received from untrusted sources, and untrusted sources are anything that we haven't trusted. Maybe the easiest thing to do, let me try. What we're doing is protecting against rogue DHCP servers. So on this guy, I don't think that I have it on here. This was one I had the native VLAN mismatch. Show run. This is kind of there and kind of not there. I think that, let's see, let me see if I can get a DHCP address on this thing. It says that it has DHCP, so let's go in here and do a IP config release and IP config /renew, and I get an address. If that was an authorized DHCP server or a rogue DHCP server, I would get that. What I'm going to do in here is go into config T and do IP DHCP snooping, and that should turn it on for the entire device. And I may make myself look silly again. So let's try a renew, and I'm not getting anything because what this thing does, my DHCP request failed. What it does is says we use the DORA discover, offer, request, and acknowledge. What it basically does is says, hey, you can't send any DHCP offer packets on this switch. But I've got a legitimate DHCP server here, and it's on gig 01. So what I can do with it is go in interface gig 0/1 and do IP DHCP snooping, and then trust it. Trust that port. So when I trust the port, it allows me to use my DHCP. I should be able to get my renew here, so I can now get the IP address. IP DHCP snooping basically keeps us from having rogue DHCP servers put into our network, and they can make a mess. We did that inadvertently one night, and the next morning the administrative people came in and they started getting IP addresses all over creation, and they couldn't get anywhere, couldn't do anything. So it validates DHCP messages, can do other things. We can do rate limits for DHCP traffic from trusted and untrusted sources. How much DHCP, but if somebody's trying to run us out of addresses, for instance, or somebody trying to just get IP addresses assigned, and because once a DHCP server runs out of addresses, it quits giving them out. Builds and manages a binding database that contains information about trusted and untrusted hosts, and uses the information to validate subsequent requests from untrusted hosts. And untrusted hosts are the one that we did here. The untrusted hosts are everything else. All of these guys are going to be untrusted hosts. The issue becomes what happens if we put some things down here and we have an option 87 that we can configure, non-packet tracer, that we can configure on the DHCP devices on the relay agent that says, okay, these are trusted kind of guys. Let's see if we can show IP DHCP snooping and do the binding. And what you see here is that when the binding database, we have the MAC address and then we have the IP address that's associated with it. Type DHCP snooping, which gives us a little bit more capability. If somebody comes in now, tries to spoof an IP address, this binding database can do a comparison with the MAC address that's supposed to be associated with that IP address. primarily designed to protect us from rogue DHCP servers. Trusted, in the enterprise, the trusted sources are the devices under our administrative control, and to make it trusted, we went into the port and just IP DHCP snooping trusted, so that I can now have a DHCP server running on it. Untrusted are devices beyond the firewall. Once I configure it, everything is untrusted except the things that we have trusted. The binding database, dynamically built. We looked at it. If you have something that needs to be in it, you can add things back to IP relations manually, so we can do manual additions to it. For each untrusted host, with the least IP address we saw, does not contain entries for hosts that are connected using the trusted interfaces. The gig01 interface wasn't there because it is on a trusted one. So we get a listing, and in this case, of everything except the DHCP server. Receive specific messages. The snooping feature updates the database. When the switch uses a DHCP ACK message, the snooping feature adds the entry to the database. So those are going to happen automatically. Database agent allows us to retain the bindings across reloads. If we reload, restart, we don't have to save it if the agent is there. If it's not there, the bindings have to be re-established after we get done with the reload. Switch is reloaded, it'll read the file, build the database. Each entry is tagged with a checksum on the first line of the initial checksum. The checksum to be sure that it is the correct one. The option 82 that I referred to, when you enable option 82 on the switch, a device will identify the switch port that it connects through, and it's going to add an option 82 to the request. The DHCP client generates a DHCP request, broadcasts the request to the network. When the switch receives the request, it'll add the option 82 information to the packet before it relays it. The switch is going to be maybe a DHCP relay agent. If we've enabled .1x port authentication, the switch will add the host's authenticated user identity to it also. If we have an IP relay agent, the switch will add the IP address to the DHCP packet, forwards the DHCP request that includes the option 82 field to the DHCP server. What the option 82 field allows when it gets back, allows the answer to come back, because as you saw, you can't get an address unless we have a trusted port. What that basically says is, okay, trust this, send it back. The switch is going to allow it through. DHCP server gets the packet. DHCP server will echo the option 82 field in the reply. Reply with a unicast. The server will then broadcast the reply when the client and the server are on the same subnet. So basic product. What all this is saying, option 82 allows the DHCP to function if we have DHCP snooping enabled. The key points, and you probably thought I was never going to get here. Default VLAN ID is assigned to trunk port. The untagged traffic will travel on the default port. Untagged traffic, native VLAN by default is VLAN 1. By default, a trunk port will be able to send traffic and receive traffic from all of the VLANs. We've said that, I think, since probably about day 2 of ICND1. Manually configure, you need to natively configure the native VLAN. Otherwise, the default will be it. Many recommend make a native VLAN to a black hole VLAN and don't put any ports on it, so that you're not going to get untagged traffic that somebody's trying to spoof something with. Local authentication and radius authentication, we looked at that a little bit. We talked about the methods and the methods lists that we use with these things. Authentication, a combination of user ID and password specified, lots of different ways to do it. Username and password is the most common way. Authorization, set of attributes, authorization, what can we do, and then accounting tracks what we did. And accounting, if we use the local authentication, and we talked about that last night, accounting is not available in local authentication. 802.1x port configured with a single host or multiple host mode, which allows a single host on a port, or we can have multiple hosts on a port. If we have multiples, then we had a single user logs in, everybody can use the port. That user logs out, port goes down, somebody else has got to log in before the others can use it again. So with that, I will quit talking.